Hello student, we do today reasoning question of alkenes. Okay, so question 1 is explain why in 2-butene 1-butene is less stable as compared to trans-2-butene. What does it mean? Trans-2-butene is more stable than 2-butene. And 1-butene means cis 2-butene and 1-butene, they are less stable as compared to trans-2-butene. So I have made this structure, draw this structure. Here the lowest is the this hydrogenation energy. More will be the stability of the alkene. See here I have written some of the heat of hydrogenation. Sometimes they are giving heat of hydrogenation and they are asking. At that moment you will get confused what to do. Okay, so in this case when they are giving you these terms, so all of them, see it is having 3 alpha H and 3 alpha 6 alpha H. This is also having 6 alpha H. Formula for this, stability of alkene is equal to number of alpha hydrogen divided by heat of hydrogenation. So in case of cis and trans, both of them having same stability, it should be same stability, but why it is not there? Because because of the steric hindrance, in the cis alkene, these two bulky groups are on the same side, so there is a steric repulsion. Okay, so that is why they are less stable. They are away from each other, so there will be very less repulsion, so that is why it is more stable. That is I told you about the from the steric regions. And secondly, it is having, the trans alkene is having 115.5 kilojoule energy, which is less as compared to cis 2-butene. Okay, and one butene is having higher this, so it is least stable. So this is most stable, trans is most stable, then cis, then followed by 1-butene. So I have written trans, cis and 1-butene. Trans 2-butene because it's a heat of hydrogenation. Hydrogenation means removal of hydrogenation means what happens? Hydrogen is added and alkane will be formed. Okay, so the amount, this is exothermic reaction and all of them will release some amount of energy, and this energy I have written. Okay, and all of them will take only 1 mole of hydrogen and will form corresponding alkane. Okay, now see here 119.7 kilojoule different energy is released, so which is having releasing less energy will be most stable. So trans 2-butene, then cis 2-butene and 1-butene, then because it is having less this heat of hydrogenation. And secondly, the second reason is it is less substituted, it is mono substituted, and rest of the other two are having, this is disubstituted, this is disubstituted. That is why 2 butenes are more stable than 1 butene, but trans butene is more stable than 2 butene, cis 2 butene, because of this steric hindrance is the reason behind it. Okay, now we'll go for the other question. Explain why the cis isomers are less stable. See here, explain why the cis isomer less stable than trans isomer in 2-butene, that I told you briefing. In case 2-butene, 2 methyl groups are located on same side, so they are closer to each other, experience greater repulsion, steric repulsion. So cis form is under great strain than trans, that is why they are less stable, and cis are less stable as compared to trans. Okay, they are more stable. Steric repulsion very less, in this case very much, so more tension, so less stability. Clear? Now although alpha hydrogens are same here, 336 both, here how many alpha hydrogen? Only 2 alpha hydrogen. So under taking example of 1-butene, we can say less number of alpha hydrogen, also less substituted, so 1-butene is the least stable. Thank you for watching.